Hello everyone. I hope you're all doing well. Okay, that's great. So, the topic that we will be studying for today is mensuration. It's part 2 of mensuration that we'll be looking at right now. Okay, and yesterday we talked about 2D shapes, we talked about area and the perimeters of shapes like trapezium, rhombus, parallelogram, triangle, most importantly, and square and rectangle. Today we'll dedicate most of our time to solving questions of firstly understanding the term of circles and the many terminologies that revolve around circles. This is actually the very confusing part. Okay, okay, so let's start. Whenever we look at a circle, we know one thing for a fact: circles don't have sides. Okay, circles, they don't have sides, so it's not easy to calculate the um, perimeter of a circle. Okay, but in order to find the perimeter of a circle, there is another thing that we have invented, that we have perhaps discovered, that's called circumference. Okay, it's called circumference. So you can say that circumference of a circle has the same idea as a perimeter of any type of a shape. Okay, now, so we understand that the idea of circumference of a circle is coming from the perimeter. Okay, but the area remains same. The phenomenon which we'd call area, that remains the same. And we need to find out what can be considered as an area in a circle. Okay, so this time around we'll be coming through a new value, a new constant in mathematics, which is known as pi. Now, the numerical value of pi is quite large. It's 3.142 and it's continuing, right? So it doesn't stop right here. But we'll assume pi as 3.14 in our syllabus, okay? So in our syllabus, the value of pi is 3.14. So now I want all of you to memorize two formulae. The first one is the circumference, oops, to find the area of a triangle, sorry, a circle. It is called pi into r squared, and the circumference or the perimeter, the formula that we use for that is called 2 pi r. Now, what is r in our case? Let's have a look. If I draw a line from one end of the circle to the other end, okay, this is a line that is traveling throughout the circle. Okay, this is a line that is traveling throughout the circle, and it starts from one end of the circle and it ends on the other one. This line is called the diameter. What is it called? Diameter. Okay, a line, and you can, if anyone wants to write the definition, it's a line that travels from one end of a circle to the other end on the opposite side. That is what you call a diameter. Now, if we want to find, if we want to find the value of r, the word r stands for radius. What's radius? Simple. Half of a diameter. Half of a diameter is called a radius. So if I stretch a line like this will be considered as the radius of the line of the circle. Okay, wait. These are the two very basic concepts that all of you must know in order to understand. Okay, understood? Yes, this is the radius basically. First write this down and then we'll understand a few more words. You all have a button for pi on your calculators, by the way. Yeah, I think if you type shift 7 on the calculator, I don't have one with me right now, I'll bring one. Okay, let's move forward. Now, there are a few other terminologies that I want all of you to understand. First things first, what is a sector? What is sector of a circle? If I was to make a circle like this and divide that circle into two parts to an extent that I have a pizza shape, wait, like this. Familiar? Okay. Yeah, consider this as a pizza slice. Okay. And this can be considered as a Pac-Man. Have you all played that game? This circle is divided into two separate sectors. Okay, two separate sectors of a circle. Now, both of these sectors have a numerical value of an angle at which they are subtended, right? This angle. Okay, we don't know what is the value of this angle, we'll calculate that later on. But this angle, the sine of this angle is represented by a symbol of theta. Okay, this is a symbol for an angle. Okay, everyone? That's great. No, these are not the circle theorems. These are these are the basic fundamental principles of what is happening inside a circle, okay? These are not the circle theorems. Circle theorems is a different topic. Should I move forward? Okay, let's move forward. So these are two sectors of a circle. This is the larger sector, and this is the smaller sector. Now I want to ask you all one question. Let's say that is theta and this angle is alpha. What does alpha plus theta equal? 360. Good. 360 degrees. Okay. These are the basic things that you all are supposed to know. Let's move forward. Now, here we have a circle, and here we have a line that touches two parts of the circle, that is touching the circle at two different points. Okay, this sort of a line is called a chord. Not a chord, a chord. What is a chord? Chord is any line that touches a circle at two different points. I need to have more space, it seems. Let's move it down without intercepting the center point. Have you all heard of center point? Oh no, I was just joking. I was just talking about a center point. There was a basically, I used to live in the Middle East, right? So in the Middle East, there was a shopping center like that by the name of Center Point. So what do I mean by this? Imagine that there is a line that is touching two different parts of a circle with the condition that it also touches the center point. What would this line be called? What would I call this line? The line in blue. Yep, we'll call this a diameter, right? This will be considered a diameter. But we don't want to have a look at a diameter. We want a line that is going through, that is touching two points of a circle, two different endpoints of a circle, without moving through the point in between. Okay? We don't want the diameter for now. Okay, I don't want to erase that. So, okay. Now, we have something else. This chord that we have here in front of us has divided the circle into two segments. Okay? This is the major segment, and this is a minor segment. So one more thing that you can write about chord is that it divides the circle into unequal segments, because if it was an equal segment, it would have been a diameter. Okay? That's great. Should I move forward? Okay. Write this down so that we can move forward. Okay, let's move forward. Okay, now we know one thing for a fact. Let me draw that Pac-Man once again. Okay? Now, this is an example of a Pac-Man, right? This is not called a Pac-Man. I'm just giving you all an example. This is an this is the angle alpha, and this is the angle theta. Okay. Now there are a few more words that I want all of you to come across. First of all, the line that I've made here. Wait. This line, okay, or perhaps this line is the radius. We know this, right? So if there is a line that is touching one end of the circle and it is also touching the center point, it may be a radius or it may be a diameter, depending if it's touching the other point as well, right? This is the radius. This part is called the arc length. What is it called? Arc length. Okay, this part is called the arc length, and just like that, this region is also the arc length. We can call this major arc length. Now, when combination of arc lengths give a complete circle, right? Yes, give a complete circle. We know this. Now, how do you find? Let's look at this region first. The pizza slice. Let's call it the region of pizza slice. Okay. I want to know two things of this. What's how to find the area of this region and how to find the arc length of this region. What do I do? What do I do? In order to find the area of this region, area of sector, it's very simple. We know that the formula for area is, what is it? Pi r square, right? For a complete circle. We know that, right? But we don't want to find the area of an entire circle, or of the entire circle. We want a part of it. We can see that there is an angle subtended at the center of the circle, which is a portion of the entire angle of 360 degrees, right? So I shall write theta upon 360 multiplied by 2 pi r squared, pi r squared, to find the area of a sector, to find the area of this pizza sauce region, this region basically. Do you understand? Done? Okay. Now, what if I want to find the numerical value of the arc length, this region? How do I do that? What's the value of the circumference? What's the formula for the circumference of a circle? 2 pi r, good. Let's write that down first. That should be multiplied by a fraction of angle subtended at the center divided by the entire angle. Once again, theta upon 360. Okay? Done? That's great. Should we solve a few questions like this? Okay. This is a new concept, so let's try to reiterate our concept a bit. Okay? Write all of this down first. Okay. Should we move forward then? That's great. Now, I want you all to solve a question in which we have a circle like this. You don't have to draw the circle, okay? And so basically, the radius of the circle is, let's say it is 8 centimeters. Oops. 8 centimeters. This is of course going to be 8 centimeters. And this is 60 degrees. I will assume that you people must know what is this. How much is this? Okay. I want all of you to find, first things first, find area of the larger sector. Then find and tell me the value of arc length of larger sector. And tell me what's the value of circumference of the circle. Okay, no, wait. I should make this a bit more challenging. Not too easy. Not the circumference of the circle. Circumference, no, basically the perimeter of this sector. Come on, everyone. I'm giving you all 3 minutes to solve this question. Yes, everyone. Are we done with the questions? What's the answer here? Okay, theta upon 360, which makes it 300 upon 360. Good. 360 multiplied by pi into 8 squared. Okay. What do we get? 167.6. Did everyone of you get the right answer? Okay, that's great. Then we have arc length of the larger sector. What's the final answer? 300 upon 360 multiplied by 2 pi r, which is 8, giving us 41.9. All of you, same answer? Is your calculator in the radian mode? Yeah, be careful with that. You might end up having the wrong answer just because your calculator would be in the radian mode. I told that in the last class. I think it's something like shift mode, then 3. 3 signifies degrees. I don't have my calculator right now with me, that's why. What's the perimeter of that sector? It's not rocket science, come on. 41.9 plus 16, because 8 and 8 are going to add up. So this entire sector is 41.9, and this is going to be 16, which gives us 57.9. Okay, I'm adding one more part of this question. Wait, yes. Now let's add this. Perimeter of entire circle. How do you solve this question? No, they won't be adding up. How to find the perimeter of this area, the perimeter of this arc length? Basically not the perimeter of this arc length, simply arc length, like this, all of this region. Because we already have this portion, this is 41.9. In order to find the area, the arc length, we need the formula theta upon 360 multiplied by 2 pi r, right? 60 upon 360 multiplied by 2 multiplied by pi multiplied by 8. What does that become? Do that on your calculators and tell me. 8.37. 8.37 plus 41.9. What does that become? 50.3. That's great. Okay, so now we're done with the topic of sectors for now. No, the class isn't ending right now. Don't be too happy. Okay, so right now let's discuss segments, okay? Let's move forward. I hope this topic is not boring, by the way. Is it? Okay. Let's just remove that for now as well. Okay. So now let's try to find areas of segments. Quick revision. What was the line that divided a circle into two separate segments? Good, a chord, right? The line that divided the area into two segments was called chord. Okay? Now, if I was to shade this segment, right? If I was to shade this segment is generally the major segment, okay? Now, I want to find the area of this segment. How would I do that? How can I? Tell me. Because it's not easy to find the areas. Like, okay, one method could be like this. Oh, not this. Wait. What would be the easiest method? Now, come on, all of you, think to the best of your ability. I want to find the area of this segment. How do I find that? Can I divide this segment as well by forming a triangle? We're just focusing on this. Leave this part for now. Okay? Leave. Leave this part. Let's form lines like this. Okay? What do I have? A triangle. Good. Let's say the value of this angle here was 40 degrees. Okay? What does this value become subsequently? 320. Good. Okay. If I want to find the area of the larger segment, area of larger segment, there is a simple formula that I can use. There's no need to memorize the formula, generally speaking. Uh, do we remember that what was the formula of a triangle when we were lacking the value of a base or a height? Yeah, we can divide this portion into two parts. Area of Pacman plus area of triangle. What was the formula of the triangle? 1 over 2 times A times B times sine of C, right? Okay. How to find the area of this Pacman? A larger segment, do you remember? Good. Theta upon 360 multiplied by pi r squared. No rocket science, right? Okay, great. Now let's solve a question like this. Should we? Let's go. Now, let's say we had, yeah, the value of this region was, let's say this was 9. Wait. The angle this forms is 60 degrees. The value of the radius is also 9. Okay? Now, I want all of you to find the area of the major segment. It's the same formula that I told you all. Okay, done. Now, area of a Pac-Man. This can be called as larger segment. We need to find the area of the larger segment, this region. 300 upon 360 multiplied by pi multiplied by 9 squared. Add this all. 1 over 2 multiplied by 9 multiplied by 9 multiplied by sine of 60. Done? Tell me what will be the answer in this case. Good. It will be 247.13. Okay, write this all down quickly. Then we'll move to other parts. Done? Okay. What if I expected from all of you to tell me what is the perimeter of the largest segment? Yes? Perimeter of the larger segment. Simple. 300 upon 360, this angle upon 360 multiplied by 2 multiplied by pi multiplied by 9. What does this become? Okay, that becomes 47.12. Good. So, do we understand the topic so far? Okay, that's great.